Hey, thank you. Good morning, good afternoon, good evening, wherever you are based out of, and thank you for joining today's call. Hopefully, this would be a good learning and a good learning webinar. Now, just to start with, I'm Nagesh Reddy, Senior Solution Architect here at Qbol. And today's topic is basically the do's and don'ts of data governance and basically other data lake trends. We're talking about mostly from data governance perspective, what is kind of required from a data governance perspective, and second is what Qbol provides you for a data governance. Yeah. So let's get started. So this is basically the topics, the agenda that we could be talking about. The first is basically governance, and as I was talking about governance, data governance. The second one is the governance at cost perspective, and third one is the latest trends, which is nothing. One of the latest trends being no code and low code, and we're talking about how you can create quick pipelines using streaming. So just going back, data governance. Now, as data has kind of exploded, every organization now have tons of data, and that data needs to be secure. Otherwise, it ends up being kind of a security threat where you collect a lot of customer data, their personal information, the companies like retail companies do collect a lot of the bank details, card details, and other stuff which gets stored uh, in the databases or uh, in the data lakes. Yeah. So it becomes very vital that you secure your data lake. There are, apart from just the policies that every company has come up with, every company or every country has come up with, like GDPR, CCPA, HIPAA. All these policies are something which make sure that okay, you make sure the customer data is secure. But apart from just securing from a government policies perspective, it has to be make sure that you secure the data from a customer perspective so that your reputation doesn't get hit. So data governance is pretty important from your own reputation and from making sure that you don't pay unnecessary fines to the governments. Now, second is we are talking about big data, data lakes here, and one of the important things in this is cost. Yeah, and it pretty much what we have seen is as you start using data lakes and big data, and you start crunching the data, processing the data, it becomes pretty uncontrollable, and your cost might spiral up, and the ROI, or return on investments that you have for processing or churning all the data might not be might not worth it to spend that money for whatever value you might be getting it. So tools like Qbol helps you kind of making sure that the cost is under control, and tools like Cost Explorer and Cluster Lifecycle Management make sure that your cost is pretty much under control. And as I was talking about latest trends, we'll talk about real time how you can, without writing too much of code or literally no code, how you can actually build a real time streaming application in Keyboard. And again, it is both quick, fast to get it up and running, and of course, with the above property to keep the cost under control with Keyboard, you can pretty much have a cost efficient streaming process. Before we dig into details, here are some of the facts that about Kibol. Kibol started in 2011, and it's basically it started as a data platform, and in 2011 it was the first, probably one of the first to start data platform, and specifically Hadoop as a service, which was niche at that moment. And at that moment, if you see, most of the companies was on-premise, still kind of crunching their big data with large softwares and nothing on cloud. Yeah, that's where Kibol came in and started everything on cloud, software as a service, Hadoop as a service, basically, and we have come up far from where we started. But yeah, that's where we started as pretty much one of the few guys who started the data platform on the cloud. Market adoption, we have seen basically from a domain perspective, every vertical, manufacturing, pharmaceutical, technology sector, and pretty much every sector that we have seen are part of the Kibol ecosystem. And second is from a location perspective, we have Asia Pacific, APAC, We have North America, we have seen South America, Europe, and pretty much everywhere in the world. Customer first, we have, since we spoke about how we make sure that big data ecosystem are cost effective, we have helped save customers 600 odd million since 2011. It keep increasing every day. Proven tested, Cubol actually manages and more than exabyte of data processing monthly. And as we speak, it keeps on increasing again. Global presence, from officers perspective or from employees perspective, we are 24 by 7 support. We have a team which is based across the world to make sure that you're supported 24 by 7. And of course, we have a free trial, 40 days free trial where you can come on. It's a pretty easy login process and setup, and you can get started right away. Now, who uses Cubol? Yeah, I spoke about Cubol that it's a data platform. It's something which will lessen your reduce your overall cost of running the big data platform. But who should use Cubol as such? That's a big question. Now, Cubol is the one who started this data platform on cloud. But on top of that, it has made big data as something which is self-service, and it has democratized the usage of big data. Yeah? Otherwise, only a select few were kind of able to use the big data ecosystem, and everything used to flow via that select few. Yeah? Somebody will ask a query, and it will come down to the select few. They will run the jobs, get the output, and share it back. Kibol has kind of democratized this, make sure that it is self-service so that the data which is stored in tons and probably terabytes and petabytes, you can make value out of that data. If you see in this chart, in this diagram, we have pretty much all the personas in the organization or enterprise that are being covered. So you have data engineers, you have data scientists who are pretty much core from a development background, and then you have data analysts, business users, and business executives who are more from a business. They are more business oriented. Yeah, they are both ends of the ecosystem in enterprise, where you have business as well as your kind of software development or engineering perspective. And engineering is something which is at core. We have tools for both sides. Engineering, like we have Python notebooks for data scientists and data engineers to write their ETL jobs or create their models. And similarly, at the business executive and data analysts, we have tools like Workbench and templates to do the analytics on top of big data. Now, since we started the topic saying that what are the do's and don'ts of data governance, one of the first thing is how do you secure the risk? Yeah? Now, data governance is all about making sure you set the right policies, data policies specifically, so that the data is accessible only by the intended user. Yeah, it doesn't fall into the hands of users who are not supposed to see that data. And as I was talking about, as organizations are collecting more and more data nowadays, and specifically the personal information data, the credit card information, the financial information, it shouldn't get leaked for whatever reason. Yeah? So you have to make sure that the internal data policies are set correctly. Second is data leaks can be security risk. Of course, it is a security risk because you're storing a lot of personal information and financial information, and it has to be governed properly. Now, what does Keepall provide to make sure that your one's data is governed properly and the security risk is kind of minimized? So you have a role-based access control. I'll talk about that in the next few slides, but role-based access control is pretty much which kind of role has got what access, and there are tools to manage that. Then data encryption. Most of the data is stored in the object storage, like in AWS it is S3, GCS, and similarly on Azure. So those are something you will use encryptions to make sure that data is stored in encryption. Audit logging make sure that any governance should have a very strong audit to make sure that you can go back and check which user has executed what kind of queries or which user has access what data to make sure that if they were intended to access the data, and then kind of rectify it if there are some issues. Now, We are talking about data governance again, and when we talk about data governance, one of the things comes with data privacy. And for data privacy perspective, as I was talking earlier, that governments have brought up a lot of policies or rules and regulations like GDPR, CCPA. These are frameworks to make sure that a personal data is not is used only for the intended purpose, and it should not be there for with you forever from an organization perspective. So it is right to forget your data, and other kind of policies are coming into play. Now, how do we do that? One of the things is from a big data perspective and data lake perspective, what we have seen is data is pretty much immutable. That means the data cannot be changed once it is there in the data lake. That has been changing over a period of time. Like initially it was high acid, and then Spark came up with something called as Delta Lakes. So we support both, but yeah, as industry is moving towards Delta Lake, I'll talk about Delta Lakes here. Now there are two things here. One is Delta Lakes where we can have right to forget, and other means implemented where you can update and delete the records, and then Apache Ranger from perspective of making sure that you have role-based access. Now, just talking about Delta Lake is basically a new table type where the lineage is something which is immutable with the asset transactions. Now, every change that you make in a Delta Lake table is kind of tracked and kind of logged. So you can go back at any point of time, that is roll back. And since it is asset-based transactions, so you can go and delete and update, you can do all those things. So it becomes GDPR compliant, the data with Delta Lakes. Then when we talk about Apache Ranger from a data governance perspective, it's basically Ranger can implement role-based access. It can enable, apart from role-based access, it can do a lot of stuff like it can go and mask the data. It can kind of control not only the tables, it can control columns, and it can go up to the very minute level. So Ranger can do not only rollback, but also data masking and other aspects, which will definitely help from a data security perspective. And the Apache Ranger also has something audit logging, basically where any user that who accesses the data, it hits the Ranger policies, and it will log each of those attempts to see who has kind of access which table, which column, and also these details are something which will be recorded in Apache Ranger. Now, we were talking about governance, and we were talking about governance at two levels. One is at data levels, and the second level is basically financial. So as we started, I said that big data and data lakes are something which are prone to cost overruns. We have to make sure that we keep our cost under control, and that was one of the main objectives when Kibol started on to cloud, making sure Hadoop as a service or big data as a service is something which is cost effective from a user perspective, because buying those big appliances on premise and kind of managing them was pretty expensive in the early part of the last decade. So basically, what are the tools which are available with Kibol to make sure that the cost is kept under control? We have something called as workload aware auto scaling. So most of the auto scaling that we might have seen as we have used is basically hardware-based auto scaling, where the auto scaling happens based on the CPU usage, or let's say a memory usage. But in case of Kibol, it added one more extra layer, which is workload aware auto scaling, where the auto scaling happens not only based on the hardware parameters, but also the SLA of the job itself. And since there is an overhead in terms of bringing a new node and then kind of commissioning and decommissioning this node, so it will try to avoid that and see that, okay, if there is a balance between creating a new node, spinning up a new node and processing in that, or if it can actually finish the job with the existing node itself, even though it might wait for probably, let's say, a minute or two. So that's just an example, but it will try to kind of keep a balance between those two rather than spinning. So when it does that, it helps you saving a lot of cost, since it is not spinning up those extra nodes. Then intelligent stack management, as we have seen in cloud, as cloud usage has increased, one of the things is basically how effectively you can use the spot management, yeah, which are kind of is very cost-effective solutions when you are using big data because you're using numerous number of servers, and then if you can keep some of them on demand, some of them spot, so you can basically manage the cost very well. So spot are like 70 to 80% cheaper than a simple on-demand instances. Now, Qbol again has kind of excelled in making sure that spot instances are used effectively. We have seen customers who are using around 100% of spot instances as well. And again, it will depend on use case, what is the criticality of the use case. Based on that, you can use either on demand or spot, and on you can increase the percentage of spots. The default is we suggest that whenever you are using a cluster, you can use a 50% of spot instances. Then heterogeneous cluster management, basically, again, this is something which is linked to spot management, where the spot instances are something which are prone to preempted by AWS, because these are freely available instances which you can grab. But at the same time, if on AWS, if there is a demand for instances, it will try to grab these and get to the on-demand pricing. Now, to make sure that Qbol gets hold of those spot instances, we have some heterogeneous nodes basically. Now, when we have heterogeneous nodes, it makes sure that it can grab an instance which are least prone to preempted. So Qbol has algorithms to make sure that it can grab the instances which are least prone to be preempted. So that makes your spot usage much better and helps you keep your cost lower. Now, one of the other things in heterogeneous cluster management is you might have different type of workloads, like let's say a CPU intensive workload, memory intensive workload. So you can create different type of clusters to cater to those requirements. You can create, taking an example of AWS, you can create a cluster with more of C type of nodes, which is compute intensive, and the M type or R type of nodes if it is more memory intensive. So job load can be managed accordingly. Cost Explorer, all those things that we spoke about was kind of how do you keep your cost low, but you have to, at the same time, you have to make sure that who is using what kind of jobs are using what kind of resources. So you need to have information about exactly what is going on your usage. Yeah. That is where Cost Explorer come into play. It can give you very minute level of details. I'll talk about those in the next slide. Now, as I was covering the Cost Explorer, this is where it is. It's a powerful tool which kind of helps you monitor all the aspects of cluster usage, manage it, and of course, because you can monitor and manage it, you can optimize the data expended. It helps you kind of identify what are kind of hotspots and helps you reduce the cost. And of course, since it helps you reduce the cost, one more aspect from this perspective is setting the budgets and tracking your spending. Yeah. So when you can set the budgets and say that, okay, this is my budget, and this we might have seen in other applications where you can set the budget and you can say, okay, if it is going beyond the budget, already will raise an alert for it. And as I was talking about, it provides you a comprehensive view of data lake cost, but in what areas. I was talking about, it goes to very low level. But if you see it can provide you cost per query. Based on this, we can see, okay, which queries are consuming more. You can probably optimize it by using partition that it can suggest. Cost Explorer can suggest that you can probably use partitions. If you don't use partitions, you would be probably reading a lot of data and processing a lot of data for just a small piece of data. If you can use partition like date-based partition, month-based, and other aspects. So it can suggest those changes as well. But yeah, this Cost Explorer provides you cost per query, cost per cluster, cost per user, cost per application. And these are just from a segregation perspective, which will give you at a higher level details what is kind of consuming the resources, and based on that, you can figure out what can go down, what kind of resources you should be using, and how you can reduce the overall cost. Okay, now we spoke about cluster lifecycle management, correct? Where, sorry, we spoke about cost explorer, which gives you lower level details of what is happening, what is the cost that is incurred on the cluster, on the jobs, on the applications. But there is another aspect which is automatically kind of taking care of your to bring down your cost. That is something cluster lifecycle management, and this has been very tedious for various organizations where other products are being used. Cubol has made sure that it is simple, effective, and it saves your cost. And what we have seen in Cubol usage with our customers is around 200 odd nodes just requires one resource from administration perspective. So that eliminates basically that reduces a lot of cost from an administration perspective, and those resources can be effectively used for managing the business or the outcomes of the business. So it automates all the provisioning, scaling, and deprovisioning of the clusters, and it provides you a single pane where you can see all the clusters, which makes it easier to kind of manage it. If you see what are the benefits of it, as I was talking about, of course, it helps you because cluster lifecycle management is there. You can set what are my minimum nodes, maximum nodes, which will help you auto scaling and downscaling at the same time. So it helps you save costs. It is more efficient because a resource need not be there who wants to provision it, deprovision it. Uh, Earlier in where you don't have workload based auto scaling or basically a load based auto scaling, it used to be kind of time based auto scaling. What we have done is because time based auto scaling is something which is inefficient. Workload aware auto scaling or basically load based auto scaling kind of helps it to save cost effectively and reduce the burden on the administrator. Increase the reliability is basically making sure that okay, it is available whenever it is required, and of course improve security. I'll show you in the demo. There are a bunch of features which will make sure that the data is kind of secured. But just to kind of give a brief just here, Cubol never processes the data in Cubol environment. Cubol is just a SaaS platform which is called as control plane, is something which is managed by Cubol, and there is other part of it which is data pane, which is data plane, which is basically managed at the customer end of it, and it is in your VPC, which in your VPC the data remains in your VPC and the processing happens on your VPC. And the third part of this webinar was basically talking about the trends, and while one of the trends that is, and most of the organization nowadays wants something like a no code or a low code kind of implementation, where they can get the use case up and running quickly. Now, Cubol has got Cubol pipeline service, which makes your data streaming applications up and running quick with literally almost zero code. And if you see, it supports Amazon Kinesis, Apache Kafka, and you can write different connectors if you want. Let's say you want to do a CDC from your MySQL, yeah, you can do the CDC using MySQL bin logs. You can do that. So built-in connectors, basically that's got shell drag and drop. As I was talking about, is pretty much no code. Pre-built operators like join, fork, and other aspects which are simple to use, those are available. And real-time monitoring of the Sparks. So underneath that, we use Spark streaming cluster, and a real-time monitoring is happening because there's a streaming. We have to know what is the backlog, how fast it is processing, and those aspects. So real-time monitoring is available, and we use Grafana at the backend to manage that. Just to recap, before we jump into the demo, governance do's and don'ts again. It's what's basically governance. Yeah, it's again a set of internal setting basically data policies to make sure that data is accessed by whoever is intended to access, and making sure that you have good auditing of whoever is accessing, so that you can go back at later point of time and see and who is being accessing and how it is being used. And this is required to make sure that you have GDPR, you have GDPR and CCPA compliant. Then, of course, HIPAA compliant based on masking and other aspects that Cost efficiency, you have financial governance. I spoke about that governance is two level. One is basically for the data, and the second is for the organization itself, which is planning big data, making sure that you don't overrun on the cost aspects and probably shut down the process. So financial governance, monitoring and managing the cost. We have cost explorer. How do we eliminate the cost? Basically, cluster life cycle management makes sure that it eliminates the wastage and use your resources effectively. Finally, the trend, basically, we are talking about Cobol data pipeline and how we can build effective streaming solutions quickly on Cobol. So let me jump onto the platform. So I'm logged in on the us.cobol.com here. But this is, we have different solutions, sorry, different platforms on US, in.cobol.com, eu.cobol.com. The reason being, again, from a data privacy perspective, we have to make sure that we have different platforms. And on top of that, we do also have, as I was talking about the data stays where in your region, so that makes sure that your data doesn't leave your region. So I'll quickly go to clusters, talk about the various engines that are available in Cobol. So if you see, we have Hadoop, we have Presto, Spark Streaming, Spark MLflow, and Airflow. I'll quickly cover these. So Hive is basically the traditional query language for the big data. I think it started with all Hive, and now of course Spark and Presto and other things have picked up. But yeah, it's from legacy perspective. If you have any, we can use it. We have Presto. Now all the data warehousing query engines, all the data is something which is managed by Presto in case of Cobol. And since it is a federated query engine, you can not only connect the data lake, which is in, let's say, object storage, but you should be able to kind of connect to any of the RDBMS or ERP databases that you might have. You can pretty much join with that. It's a federated query engine where it can connect to various data sources and query. Spark Streaming is basically the streaming engine to process all your streaming data, your IoT data, and your probably financial transaction data. Oh, sorry. Going back, Spark is again, if you have seen, most of the organizations nowadays are using Spark, and at least 99% of the enterprises are on Spark who are using big data. Yeah. For the data processing or data machine learning or pretty much analytics. So any of the tasks that you pick up probably will have big data workload, you might find Spark there. So Spark for most of the analytical workloads, you will be using Spark. MLflow for all your ML workloads, then Airflow to make sure that you have your schedulers and schedulers done properly. So we have two schedulers. We have a scheduler which is inbuilt that can take care of your simple jobs like your cron-based jobs, and it can do all those activities. But if you have something which is much more sophisticated and you want to write in Python, making sure it is a DAG complex one with forks and joins and other aspects of it, then Airflow is the one that is supposed to use it. So just going with Presto, quickly show you the various aspects because I spoke about lifecycle management. So you can provide cluster labels. Presto, we have Presto as well as Trino. You can provide master node types. That is this AWS is based on AWS. So what the instance types for master node, the instance type for worker node. Then I was talking about using multiple worker node types to make sure that you have better availability of spot instances. The minimum worker nodes, maximum worker nodes to make sure that you have better auto scaling. Then this is basically which region you want the instances to be spinned up, availability zone, EBS, and you can finally you have the cluster idle timeout. As I was talking about, the jobs or something which might run for certain duration. After that, you might not have any jobs. Yeah. So the cluster would be running idle. So if the cluster is running idle for let's say 10 minutes, you should shut down the cluster because these are ephemeral cluster. The data storage happens all in cloud, the object storage, S3s and other aspects. There's nothing which is there on the nodes per se. So you can decide since Presto. I'll show you one more parameter which is basically caching, and based on that you can identify if what is the cluster timeout. But essentially, it will make sure that the cluster is running only when it is used rather than being continuously running. Coming to composition, you have on-demand nodes, you have spot nodes, basically. Again, as I was talking about from a cost reduction perspective, we encourage using spot instances. So the minimum nodes are on demand. Usually, that's the best way so that your main your code cluster is up and running. And auto scaling worker nodes could be both on demand and spot. You can probably just use spot. Then fall back. What are the percentage of spot instances? Ideally, we keep the spot instances as 50%, just to make sure that you don't lose the job. Yeah, otherwise you will lose the entire cluster. Then what is the maximum? Because spot instances are something which needs to be bid, so we are bidding at 100% request timeout and Kubal policy. Now, next slide is something where we talk about more from a security aspect. As I was telling you that we don't process the data, Kubal doesn't process the data on its own cloud. It's essentially what is kind of processed on your account of cloud. You will select the VPCs, you will select your subnet, uh, and then you can use dedicated instances if you want, Elastic IP address, EC2 tags, just to make sure that you can do, of course, Kubal provides a lot of cost exploration, but if you want to also do on the AWS side, identify what is the AWS cost, instance cost, and other aspects, you can create these tags over here. Cluster overrides, basically you can, all those things that we spoke earlier, you can have minimum nodes, spot allocation strategy, what are the minimum node, what are the auto scaling node, time mode for master nodes, and other aspects you can set here from a cluster override perspective. Then anything that you want to change from because these are still based on Hadoop, Yarn, and others, you can update the configurations here. Then I was talking about caching. What we have observed is in Presto, caching enables speeds up the process by, let's say, 30-40%. This again kind of make sure that your cost is low. You can enable caching if you are using repetitive queries or queries which use similar kind of data. It will make sure that caching will reduce the cost. Presto settings, if you are connecting to databases, different type of databases, or any other kind of configurations, you can set this up. Monitoring, we do support Ganglia and basically Datadog if you have, you can set those up. So as I said, it's pretty straightforward. Once you have set up this, you will be able to do, and you can create as many clusters as you want with different type of workloads. For different type of workloads, you can create different type of clusters. It could be an M for a novel, or you can select something which is C for a computer itself. Now, so this was all clusters. So I spoke about Presto, but even Spark and Spark Streaming are something similar in terms of management. I'll jump to other components, basically in Kubal. So you have Explore, you have Analyze, Workbench, Smart Query templates. All these are something, and when I was talking about personas, so there are multiple personas that I spoke about. One of the business users and data analysts can use any one of these to query their data from the big data that they have, or the data lake basically. Then you have notebooks and Jupyter. Again, these are something which are data engineers, data scientists can use notebooks and Jupyters. Now you can create dashboards out of notebooks. You can make it read-only, and dashboards would be available, which can be an executed dashboard. The links can be shared and you can use for that. Pipelines, we spoke about it from data processing, streaming processing. You can use the pipelines over there. Scheduler, I spoke about Airflow already, but The other scheduler is over here for, let's say, a simple cron job or something like that. You can use the scheduler. Clusters, I just showed you the clusters in very detail, and then specifically usage, you can, I'll quickly run through that. This is basically our cost explorer where you can find the various aspects that I told about from cluster usage perspective, job usage, and everything you see in usage. And these are basically the configuration control panel where you can set up your users, set up your environments, and others. I'll jump to usage. So if you see usage here, we have various reports, status, insights, recommendation, and QCS, QQ. And QCU is basically the units of with the minimum level of units, or basically the unit level charge for Jabal. It's called as QC, and every QC has got a dollar value. So let's say cluster nodes, and then you can pick up, let's say this month, and you can submit it. It will show you the data for this month for all the different type of cluster nodes that you have. So let's give it a few seconds. So if you see here, uh, you have all these instances, all these cluster type, what are the workers which are used, what are the type of instances which are used, start time and time, what is the duration for which it got executed. So all those things will be available. Now let's go to status. So this is again a month view. It will show you what were the commands that got executed, what were the failed, cancelled, success, and so on, and how long does a query took. And this is if you see here, the QCH, basically what was spent on uh, all types and what was spent by spot. So if you see spot will be always lower, but you should try to bring up spot to a higher side so that you can save some costs. It just takes a minute or so because it has to kind of gather all those information and bring up a report. While it does that, you go to insights. It will show you all the tables. If there are some hot tables are essentially the tables which are being used more. When it comes back, again, we can go to recommendation as I was telling you that, okay, based on the queries, it can find you recommendations, of course, for partition, sort, format, what type of format that you're using, and schemas and tables, you can filter based on that, and it will provide you recommendation, and then you can say which is active, means the recommendations that are provided, which are available, and which are dissolved. If you click on QC use, basically it will show you all the analysis, monthly analysis, what has been the usage in for each one of those months, instances, basically what type of instances were used on demand or spot, hourly QCH and daily QCH, which provides you some relative details. You can download it and do some analysis if you want. So if I go back, it goes. So now if you see the field 42, success 83, it will give you those lower level details, and if you click on that, it will provide you uh, all those which were kind of succeeded. Okay, so that was basically the reporting and articles. I'll jump to Workbench. And Workbench is the one which I said can be used by both data analysts, data engineers. So you can write your Hive queries. It will automatically show you the Hive, all the Hadoop or the Hive clusters. You can do write your Presto queries, and you can use Spark, which is and you can write your Scala, Python, or R, or command line or SQL based on whatever you're comfortable with and what is your role. Based on that, you can write like a business analyst would be writing a Spark in SQL. And find all the tables here. Tables are something which are managed by height metastore in our case, and these are you can drag and drop and pretty much write the queries as quickly as possible. Instance, this gives you prompts in terms of if if the query is correct or not before even executing them. So yeah, so I'll quickly go to pipelines just for a minute. So here, if you see this is a pipeline, you have source, you can select the various sources that you might have. You have sync. You can set the properties. Basically, you can set the properties of Spark. Then, since you are using Spark streaming cluster, you can set all those properties. You have assisted code. You can write all the operators. You can drag and drop the operators, or you can write your code in your specified language, that is Python, Scala, or other. Then you can set alerts. Alerts can be set using Slack, email, webhooks, and then finally the review. You can see the pipeline and kind of deploy it at the end. You have schema registry. If you want to have a centralized schema managing the registry, you can do it. You can configure that schema registry here. So you can use any other schema types if you might be managing as at an enterprise level, and the same can be used over here in this case. Yeah, so this is a quick overview of the Kibol ecosystem. But yeah, this, as I said, it takes usually more than a few hours to kind of demo the full capabilities of Kibol. But it's, as you might have seen, the cluster setups is pretty straightforward. It is easy. The usage, the cost explorer will provide you all the details for managing the cost aspects of it, pipelines from setting up a quick streaming processes, and then workbench and notebooks for your ETL and other aspects. So I'll stop there for today. And thank you very much for joining in today. Have a great day ahead. Thank you.